This is an example of an optimization problem, and I'm going to show you exactly how it's going to be done. So this is Farmer Brown. He is building a pen for his chickens and pigs, and the pen is going to be rectangular, which means it's in the shape of a rectangle. So here's his pen, and he is going to have a divider down the center. So we will keep the pigs here and the chickens here. And he has 600 feet of fencing to use. Ultimately, you need to determine the dimensions for the pen. Okay, so for part A, we're just drawing a sketch of the pen, and we need to have dimensions. Well, the dimensions for a rectangle are length and width, and I'm going to use X, and I'm going to call this Y. And in fact, if this dimension is X, this is also going to be X, and that's going to be X as well. And if this is Y, this is also Y. I know that opposite sides of a rectangle are congruent. And let's see. For part B, determine if you are trying to maximize or minimize something. Well, earlier it said that he is going to try to find a maximum amount of area. So what we're trying to maximize, so let's write this down. We're trying to maximize area. And we need an equation. So area is X times Y. If this is a rectangle, the area of a rectangle is length times width. So this is our objective function. Our objective is to maximize area, and there is the equation for area. Now, the problem is we have two variables here. So we need to get rid of one variable in our objective function. If we're going to look at area, it needs to be a function of either X or Y, but not both, because we can't handle this. So the other thing we know is that Farmer Brown has 600 feet of fencing to use. Well, that 600 feet of fencing needs to go for here, 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 and also here and here. So what I know is that 3x plus 2y is equal to 600. So you're always going to be given a little bit of information. Our objective is to maximize area. The area is a rectangle, X times Y. But we also know that 3x plus 2y is equal to 600. So I'm going to try to get rid of the y here. So 2y is 600 minus 3x. So I'm going to solve for y. Y is 300 minus 3/2 x. And I can use this now to rewrite that objective function. So now I'm trying to maximize area, which I can write as x times 300 minus 3/2 x. Okay, so this is our objective, to maximize the area. Now, I happen to know that this is a quadratic function, and we talked about quadratic functions. So I'm going to set up a set of axes. I'm looking at area versus x. And let's see, x is in feet of fencing and area is in square feet. And I know a lot about this. Fortunately, this is factored for me. So I can find the x-intercepts. Find x-intercepts, and this is exactly what we had done in class. If I set the area equal to 0, I could use the zero product property. I'm multiplying these two things together and getting 0. So either x is 0 or 300 minus 3/2 x is equal to 0. In other words, 3/2 x is equal to 300. I'll multiply both sides by 2/3, which is going to give me x is equal to 200. So I have an x-intercept at 0, and I have an x-intercept at 200. And now we can use the fact that we know that parabolas are perfectly symmetrical. So my axis of symmetry is going to be at x is equal to 100. So I can find the vertex. I know the vertex is at 100. And if I plug 100 into this form of the objective function, so that's going to be 100 times 300 minus, well, 3/2 of 100 is 150. That's just going to give me, for an area, 100 times 150, which is 15,000. And the meaning of this is that this is the x value. This is the number of feet to use for this dimension. Whoops, for this dimension. And we are going to end up with a area of 15,000 square feet, which will be the maximum area. And let's see what else we can say. Okay, so we don't need a calculator. And okay, so Farmer Brown will have maximum area if X is 100 feet. The maximum area will be 15,000 square feet. And incidentally, let's talk a little bit about the domain. The domain here, if this was just a regular parabola that you were graphing, you know, a regular parabola usually goes on and on and on, but we don't have any use for that because we're never going to have negative area. So for this, our domain is just going to go from 0 to 200.